In this example, we'll start by writing the augmented matrix 2, -3, -1, 0, -1, 2, 1, 5, 3, -4, -1, 1. And now we'll put this into the calculator. So second matrix, go right to edit. This is a 3 by 4. And now we'll type in those entries to -3, -1, so on. After you type in those entries, make sure you double check, look for any typos, and then we'll quit the matrix, go second matrix, go right to math, scroll till we get RREF, and then second matrix, hit enter for A, and then we get a reduced matrix. In this case, we got 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1. Recognize that the coefficient matrix on the left is not an identity. So if it's not an identity, we want to look at the bottom row. This bottom row, if we translate that back into an equation, 0x plus 0y plus 0z equals 1, or more simply stated, 0 equals 1, is a false statement. If you get a reduced matrix that does not have an identity on the left, look at the bottom row. If it translates to a false statement, then that means that there is no solution to this system. And we say that this system is inconsistent. Which simply means there's no solution. Solve the system of equations using matrices. We'll start by creating the augmented matrix. 1, -3, 2, 6, -2, 1, -3, 10, 1, -8, 3, 28. Then in the calculator, we go second matrix, go right to edit, hit enter. This is a 3 by 4. And then we type in the entries. After you finish typing in all the entries, make sure you don't have any typos. And then we need to exit the matrix, second quit. From here, we'll go back to the matrix options, second matrix, go right to math, and scroll until you see RREF, hit enter, and now we need to tell the calculator what to reduce. So again, back to matrix, hit enter, close off the parenthesis, and enter one last time. So we use the RREF function, and the result is 1, 0, 1.4, -7.2, 0, 1, -0.2, -4.4, 0, 0, 0, 0. Notice that the left coefficient matrix is not an identity. So if you come across a case where the left is not an identity, you want to look at the bottom row and translate that bottom row back into an equation. In this case, 0x plus 0y plus 0z equals 0, or 0 equals 0. That is a true statement. Since it's a true statement, that means we have an infinite number of solutions. The way to answer this now is to go to the top two equations and rewrite these. So this first row we can translate back to x plus 1.4z equals negative 7.2. And then the middle row is y minus 0.2z equals negative 4.4. From here, we want to rewrite those in terms of the same variable. So we can rewrite x in terms of z and rewrite y in terms of z. So our final answer is going to be all x, y, z, such that x equals, solving that top equation for x, we get negative 1.4z minus 7.2, and then y equals, we'll solve the second equation for y is equal to 0.2z minus 4.4, and then z can be any real number. This entire statement is our answer.